Hello, this is Scholar Strive doing some math today in Algebra 2. We're going to look at logarithmic functions. Logs. So, first thing we're going to do is, what is a log? Oh. And we're going to use an exponential function to show you what a log is. So, let's have the graph y equals 2 to the x. It's an exponential function, because the exponent is our variable there. So is the inverse a function? So the domain, x belongs to all real numbers. It's like a weird E that looks kind of like that, but that means belongs to. Our range is greater than 0. And our inverse, well, let's look at the graph first. So, if you remember from before, 2 to the 0 is 1. 2 to the negative first is 1/2. And 2 to the first is 2. 2 to the squared is 4. 2 cubed is 8. And so on. And this is what our graph looks like. And we have an asymptote here at y equals 0. So remember, our inverse is all we do is switch x and y. So our inverse is x equals 2 to the y. So what's the domain? Our domain this time is, if we switch things around, that means x is greater than 0, because we'll have a vertical asymptote, and our range, y, is going to belong to all real numbers. Because I'm just changing my x and y in my table. So like if I have an xy table, if we're looking at the original graph, if I plug in -1, I get 1/2. 0, I get 1, 2, or 1, I get 2. All I'm doing is switching my x and y. That's how you find the inverse. So this inverse is actually a reflection over the line y equals x. And our inverse kind of looks something like this. So we're just switching our x and y. So we're going to have -1, 0, 1 here. That's going to be 1/2. It's going to be 1. And that's going to be 2. And this is going to be 4. And 8. Okay. So if I go to 1/2, that's -1. 1, 0, 2, 1. 4, 2, 8, 3, so it just looks like that. Kind of made this bottom part a little curvy. And this inverse is what we call our logarithm. Alright, so this is where logarithms came from. It's just the inverse of our exponential. So logarithm of y with base b is log base b of y equals x. If and only if b to the x equals y and b is not equal to 1. Y must be positive, b must be positive. A common logarithm is a logarithm with base 10. So whenever you see, so normally you write log base 10 of x in your calculator, you'll just see log. And that's what it means. It means log base 10. Alright, let's see what's next. Here, natural log. So this one is a logarithm with base e. So if you wanted to write log base e of x, you would call it just ln of x. So you would see that on your calculator too. You would see log, and that means log base 10, and then ln means log base e. Okay? So let's rewrite these log base b's into something we like to use. So in general, log base b of y equals x if and only if b dx equals what? Okay? So I'm going to change this logarithm form into exponential form. So the base, so remember base of an exponent, so base 2, so I write 2 to the x equals 32. And what number should the exponent be? 2 to the what power is 32? That is 5. So this is 2 to the 5th equals 32. So log base 10 to the 1st. So this is 10 to what power is 1. And that is 0. Nine to what power is 9? And that's 9 to the 1st. 1/5, that's our base, to what power equals 25. Now if you've gotten used to your exponents, you'll notice that 1/5, I'll write it right here, 1/5 to the negative 2 is actually equal to 25. Alright, exponential form, logarithmic form. Here we go. So we start out with 2 to the 3 equals 8. So we're going to say log base 2 of 8 equals 3. Log base 5 of 1 equals 0. Log base 7 of 7 equals 1. Log base 1/3 of 3 equals -1. Alright, let's move on. Properties and special logarithms. So the log of 1 is always 0. And we'll show you why. Log base b of, with any base, of 1 equals 0, because if we write it in exponential form, b to the what power equals 1? Well, that's b to the 0. Okay, log base b of b. So log base b of b equals 1. Because b to what power is itself? That is 1. Common log. Just reading and writing this again. Just remember log base 10 is the same thing as log. Okay. And log base e is the same thing as natural log. Alright, evaluate the logarithm. So 3 to what power here equals 81. So it's good to know some of your exponents here. 3 to the 4th equals 81. 1/4 to what power equals 256. So luckily, we know that 1/4. So if we just look at 4 squared is 16. 4 cubed is 16 times 16, which is, 16 times 4 is 64. So, and then 4 to the 4th is 256. So 1/4 to the -4 will give me 256. Alright, let's see. Log base 10 of 0.001. Okay, so 10 to what power is 0.001. We should know this as 10 to the -4. Okay, because this is, remember, 1/10 to the 4th power. And that's how you get, that's just dividing by 10, divided by 10, divided by 10, divided by 10. 8 to what power is 2? So how do we get from 8 to 2? We take the cubed root, and that is the same as 8 to the 1/3. 5 to what power is 1/25? That would be 5 to the -2nd. So a lot of these, I mean, you're going to practice using numbers that you could remember with enough practice and experience. But you're never going to do something that doesn't have like a perfect exponent, like or a perfect square or something like that. It'll always be some combination of, it's like 5 to the something or 6 to the something. And it's not going to be 6.25 to the something power. You'll be able to figure it out. Inverses. If f and x and g of x are inverses, then f of g of x equals x, and g of f of x equals x. So remember these composition of functions. And then since logarithmic functions and exponential functions are inverses, we can say f of g of x, which is the same thing as b to the log base b of x equals x, and then vice versa, g of f of x equals, so if we take the log with base b of b to the x, basically the b's cancel and you're left with x. Same thing on the left side there. If you take b to the log of base b, then those will cancel. Alright. Find the inverse. So remember, when finding the inverse, step 1, switch. So step 1, if you don't remember, switch x and y. So x equals 10 to the y. Okay. Then rewrite as log. So this would be y equals log base 10 of x. Or you can say log of x. Okay. So once again, part B, we're going to switch x and y. So x equals ln of y minus 5. So remember, ln is natural log. It's log base e. Okay. How I like to look at it is I'm trying to get y by itself. So I got a free y. So I have to do the inverse operation. If I have natural log, then I'm going to e both sides. Okay. So this will be e to the x equals e to the ln of y minus 5. And since they're inverses of each other, they cancel each other out. So I'm left with e to the x equals y minus 5. I add I add 5 over. And I get y equals e to the x plus 5. And that's my inverse. Okay? So you're always doing your base. So those are your two different methods. I like part B because you use the inverse like you do all your other problems. If I'm multiplying a number to a variable, then I divide both sides to get rid of that number. If I'm dividing, then I multiply. If I'm adding, I'm subtracting. If I'm subtracting, if I'm adding. If I'm doing the natural log, I'm doing e. And if I'm doing log base 4, okay, so first off, switch x and y. So x equals log base 4 of y minus 2 plus 1. Okay, first thing I'm going to do is try to get y by itself, so I'm going to subtract the 1 over, because that's not included with the log. So I have x minus 1 equals log base 4 of y minus 2. Okay, so the inverse of log base 4 is taking this, raising everything to the exponent. So what I'm doing is raising everything to the exponent and having my base be 4. So I'm going to have 4 to the x minus 1 equals 4 to the log base 4 of y minus 2. So base 4 to the log of base 4 cancels out, and I'm left with 4 to the x minus 1 equals y minus 2. And then add 2 over, and we'll get y equals 4 to the x plus 1, or x minus 1 plus 2. And that is our inverse. Hopefully this helps you out. Have a good day.